Welcome to Now You Know Academy. Today we're going to be going over R and S nomenclature for asymmetrical carbon atoms. First thing to know about this, there are two important steps. Number one is assign priorities to the four groups attached to the chiral carbon atom by atomic number, from number one, which has the highest atomic number, to number four, which has the lowest atomic number. Okay? And there's two parts, additional parts to this. There's 1A, which is if there's a tie, move away one atom at a time until you find a difference, okay? And 1B is treat double bonds as two single bonds, and triple bonds are treated as three single bonds, okay? I'm gonna give some examples on both of these, so don't worry. The second big part is with the lowest priority group pointing away. Okay, that's big. Lowest priority group going back. And by back, that means dashed line. Okay, dashed line. From you, go from number one to number two to number three. If rotation is clockwise, then the carbon is designated as R. If the rotation is counterclockwise, the carbon is designated as S. Okay? Feel free to pause the video right here so you can get that down in your notes. Okay? Let's look at some examples. With the lowest priority group going back. Okay? So, we're going to assign priority groups. The way we do this is based off the periodic table, and we use in particular the atomic numbers. So like 84 for that one. For bromine, it's 35, chlorine 17. So those are the atomic numbers that we're going to be using for this. So we're going to look at this example. We're going to look at this chiral center, okay, this stereo center, and we're going to assign priority groups of the atoms attached to it. When I mean atoms attached to it, I mean like this oxygen is attached to it. Okay, this bromine is attached to it. This hydrogen is attached to it, and this methyl group is attached to it. So this is how we're gonna do it. If you look at it, we have a bromine and oxygen. We know bromine is one priority because if we look over here at the periodic table, it's number 35. It beats oxygen, which is number 8. So oxygen is our second priority. Then we have this methyl group, which is a carbon with 3 hydrogens on it. We compare the carbon to the hydrogen. We know carbon is higher atomic number than hydrogen, so that's third priority group, and then hydrogen's fourth priority group, okay? We make sure that our lowest priority group is going back. In this case, our hydrogen, our fourth priority group, is going back. So what we do is we just number from 1 to 2 to 3. This rotation is counterclockwise, so our designation is S. Okay? Let's look at another example. Okay? You should know that there's a hydrogen attached here. It's a dashed line because we have a wedge on it, so that means the only available one is the dash. We're going to go and we're going to assign priority. Okay? So we look at the atoms directly attached to this carbon. So this carbon here, the nitrogen, right? And the hydrogen. All right? So we're going to go in and assign priority groups. So it's connected to a carbon, hydrogen, nitrogen. Nitrogen is the highest atomic number, so nitrogen is our first priority group. And then if you realize we have a tie. So this is how we break a tie. Let's look over here on the left carbon. Our chiral center is connected to a carbon, so that's what this carbon designated. This carbon is then connected to an oxygen, a carbon, and another carbon. So we have a carbon connected to an oxygen, carbon, carbon. Okay, now let's look on the right one. Let's look over here. We have this carbon. So that carbon is connected to oxygen, but it's double bond to oxygen. So the double bond is like this. We have our carbon, and this is how we're going to treat it, as a carbon bond to a oxygen twice, so oxygen, oxygen, and then a methyl group, so a carbon. Okay, now we're going to compare these two. We're going to look at it. We have on the right carbon, we have 2 oxygens, and on the left carbon, we have 1 oxygen. So that being said, the right carbon is our second priority group. The left carbon is our third priority group. And our fourth priority group is the hydrogen. Okay? Our lowest priority group is this hydrogen. It's our fourth group, and it's going back. So we just go from 1 to 2 to 3. This is counterclockwise. So this is also S. Okay? Let's look at a different situation. In this situation, the lowest priority is coming forward. Okay, so we're gonna look at this carbon right here. Okay, we're gonna assign priority groups. Okay, so nitrogen is first because it has the highest atomic number. We have 2 carbons here for another tie, so we're gonna analyze these. We have this carbon up top is a carbon connected to, we have this double bond, so remember that means it's bonded to oxygen twice, and then it's single bond to that hydroxyl group, so another oxygen. We have this carbon, it's bonded to 1 oxygen right here, and 2 hydrogens. Okay, we're going to analyze these. This carbon has 3 oxygens, this carbon only has 1 oxygen. So that being said, the top carbon is our second priority group. Then the next carbon is our third priority group, and lastly, our hydrogen is our fourth priority group. However, now we want to look at if our fourth priority group is going back, and however, in this case, it's coming forward. So what we want to do is get it going back, and how we do that is we're going to take our fourth priority group and switch it with our third priority group. So we're going to take that hydrogen and put it on that dashed line, and we're going to take that carbon attached to that oxygen and put it on our wedge line. Okay, so what we're going to do is we're going to switch groups 3 with group 4. Okay, and when we do that, we should get this. Okay, look, all I did was switch around this, look at the top one, this CHO2, and moved it where this hydrogen is, and took this hydrogen and moved it on that wedge step line. Okay, so we did a switch. We're going to bring down our priorities, which we already designated. Those don't change. Okay, and now we're gonna check to make sure our lowest priority group is going back. In this case, it is. Our hydrogen's on a wedge line going on a dash line going back. We're gonna go from our 1 to 2 to 3. Okay, and we get R. Okay, however, it's important to note that we did this switch. Okay, and when we do a switch where you switch your lowest priority with any other priority, you have to invert stereochemistry. So it's actually not going to be R. You're going to invert your stereochemistry to be S. Okay, because you did that switch, you're converting it to S. So what this is saying is this set carbon up here, this carbon is S configuration. All right, so let me put that in red. Okay, so that carbon is S configuration. And you solve that by switching the lowest priority to get it in the back, then assigning R and S and switching that R and S. Okay, and that's going to get you your R and S configuration when your lowest priority is coming forward compared to going back. Let's look at the next one, where our lowest priority group is in the plane of the page. Okay, so let's assign priority groups. We know oxygen is highest, is 8. Then we have our nitrogen, which is second. Carbon is third, and hydrogen is 4. Okay, if you don't see that, our nitrogen is number 7 atomic mass, carbon is number 6, and 4 would be hydrogen, which is number 1. Okay, Now we make sure that our lowest priority group is going back. In this case, it isn't going back. It is in the plane of the page. So what we have to do is we gotta switch it with the one going back. In this case, we're gonna switch group 2 with group 4, okay? So we're gonna switch group 2 with group 4. And you're gonna get this when you switch those two. All you're doing is taking that hydrogen and moving it where this nitrogen is, and taking this nitrogen and putting it on that in the plane of the board. Okay, so you're gonna get this new configuration. We're gonna go ahead and bring down our priority groups. They don't change. Okay, and then now that we have our lowest priority group going back, we're going to go from 1 to 2 to 3, which gives us counterclockwise, which is S, but we have this switch, right, because we switched them, so our priorities actually are, okay? So what this is saying is that this carbon is our configuration, okay? And how we did that is we switched our lowest priority group so it's going back, and then assigned RNS configuration, and then just inverted or switched from whatever we got down here, okay, to give us the proper orientation for our original carbon, okay? So go ahead and try this practice problem. I numbered the 2 stereocenters. So how you're going to do this is you're going to, in the comments, feel free to leave your answers as like 1 and then whatever RS designation you have for there, and then 2 and whatever RNS designation you have for there, okay? So like I said, leave your answer in the comments. Don't forget to like, subscribe, and hit the bell for more Now You Know lessons. And as always, check out the extra resources in the comments, including extra practice and answer key. Thank you for watching, and good luck.